Was the Spinosaurus the ultimate river monster, or just an oversized wader stuck in the mud? For decades, we pictured this dinosaur walking the earth like a T-Rex with a sail. But the deeper we look into the fossil record, the more that image falls apart. By reconstructing its center of gravity and analyzing the physics of ancient river systems, we are finally solving the aquatic origin theory. Join us as we dive deep into the data to see if this predator truly dominated the depths or if it was just a giant bird-like hunter dipping its toes in the water. The bone density breakthrough. To understand how an animal lives, you have to look inside its bones. Recent histological data from 2024 and 2025 have given us a massive breakthrough. When we compare the bone compactness of Spinosaurus to modern animals like hippos and penguins, the results are undeniable. Most theropod dinosaurs, the meat-eaters we know and love, had hollow, light bones to help them run fast on land. But Spinosaurus was different. Its bones were incredibly dense and heavy. In biology, high bone density is the smoking gun for habitual submersion. Just like a scuba diver wears a weighted belt to keep from bobbing to the surface, Spinosaurus used its natural skeleton as ballast. This wasn't an animal that just went for a quick dip. It was biologically weighted to stay under the water. The center of gravity paradox. Even with heavy bones, a massive predator needs balance. Using new digital 3D scans, scientists have discovered a center of gravity paradox. On land, Spinosaurus was incredibly front-heavy. If it tried to walk on two legs like a typical dinosaur, its weight distribution would cause it to tip forward. However, when you put that same model into a deep river, everything changes. By calculating the buoyancy of its massive air-filled lungs against its heavy skeletal frame, we found the exact hover depth. In a river system, this dinosaur wouldn't have been clumsy, it would have been perfectly buoyant. This balance allowed it to hang in the water column, reacting to river currents with the stability of a submarine rather than the wobbling of a land animal. Propulsion and the tadpole tail. In 2020, the discovery of a nearly complete tail changed everything. It wasn't a stiff, tapering tail of a land dweller. It was shaped like a giant paddle. We've put this tadpole tail through 2026 fluid dynamics software to measure exactly how much thrust it could produce. When we compare the side-to-side motion of the Spinosaurus tail to the efficient swimming strokes of modern crocodiles, the power is staggering. This massive oar was more than just a stabilizer. It was a high-powered motor. While some scientists wondered if it was too slow to catch agile prehistoric fish, the data suggests that in a confined space of a river, this tail provided the perfect combination of thrust and steering to corner prey that had nowhere else to run. The crocodile mimicry test. The final piece of the puzzle is on the tip of its nose. If you look at the snout of a Spinosaurus, you'll see tiny sensory pits. These are almost identical to the organs modern crocodiles use to detect tiny vibrations and pressure changes in the water. This settles a major debate. Was it a stork-like hunter striking from the bank, or an ambush from below specialist? Based on the flexibility of its neck vertebrae and these specialized sensors, the evidence points to the water. It didn't need to see its prey in murky rivers. It could feel them coming. This biological profile paints a picture of a specialized hunter that was more at home in the current than on the shore. Verdict on the River King. When we synthesize the bone density, the propulsion of the tail, and the sensory data, the verdict is clear. Spinosaurus was a pursuit predator, a high-speed hunter designed for life in the water. By mapping the Cretaceous African river systems, we can see a world of deep, wide channels where this titan would have spent 80% of its life. We must conclude by redefining the Spinosaurus. It wasn't a failed land dweller or a dinosaur experiencing an identity crisis. It was the most successful aquatic experiment in dinosaur history.